Module 4, Lesson 8, Replacing Numbers with Letters. So we're going to work on some notes for today's lesson. So we're going to have a lot of properties and identities. That's what today's lesson is about. We're going to talk about all of those and give some examples as well. So the first one we're going to look at is the additive identity property of 0. So what that says is that G plus 0 equals G. And what that means is any number plus 0, you get itself back. Okay, so you could replace the G with any variable. Remember, the letter is a variable. So any number added to 0 equals itself. Okay, so an example of that might be 2 plus 0 equals 2. Okay, so that would be a simple example. So that any number, when you add 0, you get the same number back. These are probably things that you already know. You just might not have known they were called an identity or a property. The next one is called the multiplicative property of 1. So when you see that word multiplicative, hopefully you in that you hear and see the word multiply, which is what this property has to do with. And what this property says is that any number times 1 or multiplied by 1 equals itself. So G times 1 equals G. An example of that would be, let's say, 9 times 1 equals 9. So any number, no matter what it is, if you multiply it by 1, it just equals itself. Okay? And that, again, is the multiplicative property of 1. And the next property that we're going to look at is the commutative property of addition. And this is also something else that you probably have known but didn't realize it was given a name. And what that says is A plus B equals B plus A. So order does not matter when adding. So for example, if I'm going to pick two numbers to replace A and B with, if I say 3 plus 4 equals, and then I switch those around, 4 plus 3. So we know 3 plus 4 equals 7 and 4 plus 3 equals 7. So this is just saying the order doesn't matter. You're going to get the same answer. The sum is going to be the same, which is the answer to an addition problem. And again, that's called the commutative property of addition. The next one is the commutative property of multiplication. So the same idea. It kind of goes along with our fact families that we've talked about. Like I always say, once you know one fact, you really know 4. Well, definitely when you know one multiplication fact, you definitely know 2. Because A times B equals or is the same as B times A. So order does not matter also when you're multiplying. And that even includes large numbers. So let's say, for example, it was 25 times 36. Well, that would equal 36 times 25. So it doesn't matter the order. If you put 25 times 36 in your calculator or multiplied it on your paper and then did 36 times 25, you would come up with the same answer. The product would be the same. So order does not matter when multiplying, and that's the commutative property of multiplication. So obviously I write big. I need to turn my page for the rest of the notes, so I'm going to do that. So some other identities are properties that may not have a name, but things that you know or see. So first of all, A plus A plus A plus A equals B times A. So what that means is that we can use that repeated addition for multiplication. And we've talked about this. We talked about that at the beginning of this module with our addition expressions. So an example of that would be that 3 plus 3 plus 3 plus 3 is the same as 4 times 3. And all of these 3's added are 12, and 4 times 3 is 12. So I just kind of put a little parenthesis and the word true, because that is true. Another important thing to remember is that G divided by 1 equals G. So if a number is divided into one part, the size of that part is that same number back. Okay? So if I were to do an example of this, it would be maybe like 4 divided by 1 equals 4. So anytime you have a number and you divide by 1, you're going to get that same number back. The next thing we need to look at that's also can be important is that also any non-zero number divided by itself equals 1. What non-zero means is any number that's not 0. So starting at 1 and continuing on. So any non-zero number divided by itself equals 1. G divided by G equals 1. So an example of that would be 6 divided by 6 equals 1. Think about why the non-zero, why it says non-zero. What happens if we divide 0 by 0? So let's think about that. If I have 0 divided by 0, what happens? Obviously, I have 0. So that's why any non-zero number divided by itself equals 1. Because when you divide 0 by itself, it's 0. Because if you don't have anything to start with, which is 0, and you divide by 0, you're still not going to have anything. Okay? So just remembering those things. Another good thing to remember is that any number multiplied by 0 is 0. And I know these seem simple, but sometimes when we're working through equations or expressions or even through long division things that we're doing, these are important to keep in our mind. So any number multiplied by 0 is 0. So I can pick any number. If I were to do that as an equation, I might say G times 0 equals 0. And an example of that might be 31 times 0 equals 0. Okay, so the lesson in the book we're actually not going to do today. We're going to do the exit ticket that I passed out to you. So I'd like for you to take a look at that. So this exit ticket is asking you to use the properties that we just talked about and give an example. So for example, number 1 on the exit ticket says state the commutative property of addition and provide an example using 2 different numbers. Well, in our notes, we talk about the commutative property of addition right here, okay? And we give an example. You need to give a different example than the one we gave, but you need to write what it means and then also give an example, okay? Number 2 says state the commutative property of multiplication. Again, that's in our notes that we just did, and provide an example using 2 different numbers. So I know it says 2 different numbers, but for each one you're providing 1 example. Make sure it's a different example than we have in our notes, and make sure you also state what each property means. So tell the meaning of it. Number 3, state the additive property of 0, which we also talked about in our notes. That was this very first one, additive property of 0. So again, you're going to state what it means, and you're going to give an example. Okay, please make sure you do not use the example that we gave. Use a different one. And then last, state the multiplicative identity property of 1, again, that is also in our notes, and provide an example. And again, you want to make sure you use a different example than what we have in our notes. So all 4 are a must. Make sure you state it. Remember, part of stating it is giving the property with the variable. So what I mean by that is, for example, when they say that state the commutative property of addition, this A plus B equals B plus A is stating the commutative property. Also saying order does not matter when adding. So when you're explaining the commutative property of addition, you want to give the equation that goes with it as well as the words. So that's what they mean by state. And then you also want to provide an example using numbers, and how you choose to, what numbers you choose to use are up to you. Just use different ones than we used in our notes. When you're finished with the exit ticket, please make sure that you have your name on it. That's important, name. And then turn it into the inbox.